Pardon me? Of course. That takes care of a whole bunch of elements. And if we go here, where'd it go? There we are. You should be aware that there are several elements which are diatomic when we find them in nature. Would oxygen want to be on its own? Right? It'd be like, oh, I'm not really very happy with these two gaping holes in my outer shell. I would rather be bonded with another oxygen so that I have a complete outer shell. So oxygen, chlorine, fluorine, bromine, iodine, all the ones in this list here, when we find them in nature, they are in the form of molecules made of two atoms. In other words, diatomic molecules. What does the prefix di mean? Two. So diatomic means two atom molecules, absolutely. And at some point in your chemistry career, you will be expected to memorize these. So I thought I would start you out with it this year, all right, so that you can remember it this year, then you'll have to do it next year, and then you'll have to do it in grade 11. And by the time you get to grade 11, it'll become second nature and you won't have to think about it too hard. So we have, one way of remembering it is Dr. Brinkelhoff. Brinkelhoff. So we have BRI, so BRI, and then NClHOF. Brinkelhoff. So if you forget who the diatomic elements are, who are you going to ask? Dr. Brinkelhoff. Okay? But that's not all. There's many other ways to remember it as well. There is the hockey stick and puck method. Okay? And this actually takes advantage of the fact that how many of these diatomic elements are there? 7. So there are 7 diatomic elements. Lucky number 7, right? If you go to element number 7, who is element number 7 on your periodic table? Get your periodic table out, because you might want to draw on it. Nitrogen is number 7. So you're going to start on element number 7, and you are going to draw a 7. Ooh, look at that. But if you count them up, if you have drawn that 7 and you count them up, there's only 1, 2, 3, 4, 5, 6. So that's your hockey stick. In order to get 7, you also need the puck. So here we have the hockey stick. And here we have the puck to give you 7. So start on 7, draw a 7, and then add hydrogen as the puck. Yes? Sulfur tends to form ring structures where it has 8, what you call it, 8 atoms in a molecule. It has It has 6 electrons in its valence shell. I'm not really quite sure why. I'm guessing it has to do with the fact that it has empty 3D subshells, but we don't know about those, so we're going to pretend I never said anything. Okay? But I honestly don't know why. I don't know why it's not S2. Okay? All right. So that's the second way to remember it. And then a third way, if you don't like any of those, and this one's easy to remember, but it's also easy to get things wrong if you don't remember it correctly. Okay? And this is one I got from Tyler DeWitt. It is have no fear of ice cold beer, which a lot of people find really easy to remember. The only problem is often what people will do is they'll say, okay, I got H2, N2, F2, O2, I2. That's great. They get to the cold and they're like, carbon 2 or cobalt 2. It's not carbon, it's not cobalt, it is chlorine. And with bromine, sometimes we'll get boron 2. Sometimes people are like beryllium 2. It's neither of those, it is Br2. So of the 3 methods, that's my least favorite because it does tend to lead to people making mistakes in remembering it. But if you can remember that it's cold and beer, then you're okay. All right? So whichever method works better for you. I had someone once tell me, I don't like any of those. It's easy enough to just memorize them. And I'm like, that is A-okay by me. So, all right. Now we're going to do some covalent bonding of compounds. And once again, here we have a hydrogen. How many electrons does hydrogen need to have a full shell? 2. That's the only exception to the 8 rule that you need to know for grade 9, is that hydrogen only needs 2. Chlorine, on the other hand, needs 8. So if they share 2 electrons, then you, whoa, that was supposed to be a highlighter. If you share those 2 electrons, then you have a complete structure. And we did use this compound earlier this year in one of our experiments. HCl is hydro for the hydrogen, chloric for the chlorine, and then it is an acids. Acids are compounds that begin with H, just for anyone who's interested. That's an optional thing to know. We'll do that in grade 10. Ooh, here's a question for you. If I was to give you the formula HBr, first of all, what type of compound is it? It is a covalent compound, and specifically it is an acid, right? Because it's got that H at the front. Could you try telling your partner what the name of this acid would be? That's just a little challenge for you here. Anyone want to take a guess? Hydrobromic acid. And what if we had HF? Hydrofluoric acid. Okay, this will be part of the enriched stuff for next unit. So obviously you do not need to know it for this unit, so I will put little diamonds beside it so that you don't write it down and think you need to memorize it. Okay, so you do not need to know that for this unit. Hydrochloric is sort of like the most famous acid. It's the most common acid that we use in chemical experiments other than vinegar, which is acetic acid. Okay. All right, let's take a look at CO2. First of all, what is the name of CO2? You probably already know. Carbon dioxide. And when we have a covalent compound, very often we will tell you how many of the oxygens there are by putting a di in front of it, but we don't do that for ionic compounds. Okay, so MgF2 would not be magnesium difluoride, it's just magnesium fluoride. Okay, so that means there's two oxygens. So we have a carbon. And if you have a choice, if you aren't told where the atoms go, the singleton atom will go in the middle. What does that mean? What is a singleton atom? It's a lone atom. It's like there's just one of them. So how many carbons are there in carbon dioxide? Just one. Messing with me. Okay. So we're going to put the carbon in the middle. And we're going to put the oxygens on either side. Huh? Yes. So what happens is in your body, we breathe in the oxygen, and the oxygen reacts with sugar. C6H12O6. That's glucose. Okay? That's sugar. Now what happens is that those two things react together, and the carbon is going to get together with some of that oxygen, and the hydrogen is going to get together with some of that oxygen, and they're going to recombine in a chemical reaction, right? You remember how in chemical reactions the particles switch partners and do things like that? The carbon's going to get together with oxygen and form CO2. The hydrogen's going to get together with oxygen and form, can you guess what? What do we get when we put hydrogen and oxygen together? We get water, H2O. So this is the reaction that actually happens in all the cells of your body that it also gives off energy. And this is the energy that is used to move your muscles, to power your brain, to do, basically if your body needs energy to do anything, this is the reaction that powers it. Okay, it's actually a lot more complicated than that. If you take biology 12, you'll learn there's various pathways that you go through to eventually get this, and then there's different forms the energy comes out in, but that's basically it. And you know what's really magical? Do you know what plants do? Plants take carbon dioxide and they put it together with water, and you get sugar and oxygen. Pardon me? They just want the sugar so the oxygen comes out into the air. Isn't that beautiful? Now, to be fair, they also use this process. So they are actually taking energy from the sunlight to drive this process forward. So you have to have sunlight in order for that process to occur. It won't happen otherwise. Exactly. Exactly. So we eat sugar from the plant, or we eat if we're eating meat, the cow or whatever it is got the sugar from the plant. And yeah, so we're all actually eventually getting energy from the sun. It's all coming from the sun as our original source. Anywho, that's kind of a little bit of science 10. You would be writing reactions like that. And a little bit of biology 11 and 12. Okay, but oh, do you guys know what this process is called where we take CO2 and H2O and make oxygen? Starts with a P. Photosynthesis. Does anyone know the reverse process? Cellular respiration, yes. Okay, that's just kind of because it's interesting, all right? It's not part of grade 9, but I find it fascinating. Okay, back to our carbon dioxide. How many valence electrons in carbon? It's in group 14, therefore it has 4. Oxygen has 6 valence electrons. Is this in group 16? So carbon, 1, 2, 3, 4. Oxygen, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How could we have these guys overlap so that everybody ends up with 8? Yeah, exactly. So what we're going to do is we're going to take these two guys and put them in the middle, and we're going to take these two guys and put them in the middle. So we'll have 1, 2, 3, 4. And then we will take these two and share them, and these two and share them. So we will have 1, 2, 3, 4. And then, of course, we have our lone pairs left on the oxygens. So our carbon is in the middle. Our oxygens are on the outside. La, la, la. La, 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 la. La, la, la. La, 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 la. And now everybody has 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we're all happy and joyful. And I think you guys want to do a little bit of practice on drawing these? No? Okay, so we are starting on page 87. 87. So on page 87, we have some fill in the blanks. This down here is our word bank. I didn't label it very well, did I? That's our word bank. And you're going to use it to fill in the blanks. And just so you know, for this one, the names can be kind of tricky. So if you don't know the name, you can feel free to ask me. A lot of the names have black diamonds beside it, which means that you're not responsible for knowing it. Okay, so don't even worry about that if it's got a black diamond beside it. If you want to know it, let me know, but you're not required to. Okay. So start on page 87 and work your way through to page 95 if you can.